Welcome back to Math Concepts. In this video we are going to talk about the concept of a Venn diagram. It gives us a very useful way to visualize the set operations of union, intersection, and complement that we have talked about in the course so far. So let's get right to the document camera and look at some examples of using Venn diagrams. So when we are drawing a Venn diagram, we want a couple things in place. We want a box that indicates the universal set, and we want a circle for each set that we're talking about. It'll be clear once we work through some examples. So we're going to draw Venn diagrams for each set. So we want the set A intersect B. Okay, so I've got my box representing the universal set. I'll even label that U. I have a circle representing A, so the interior of that circle represents all the elements in A. And here I've got a circle representing the set B. Now, we know from a previous video what the intersection of two sets is doing. The intersection of two sets is forming a new set by selecting the elements that A and B have in common. And that would be represented by this area right here in the Venn diagram. Okay, so typically when we're talking about a set or set operations in a Venn diagram, we indicate the result with some shading like that. Okay, let's do a couple of other examples. Okay, so A union B. Okay, pretty simple to do here. Once again, we have our box for the universal set, circle for A, and a circle for B. Okay, now when you're drawing these Venn diagrams, please make sure you label your sets. Now, the operation of union, as we discussed in the last video, the union is a new set that we form by taking all the elements of A together with all the elements of B, making one big set. So everything in A will be shaded, as well as everything in B. Okay, so the union of two sets is bigger than either of the sets individually. Okay, so here, I'm going to do a little scratch work for this one here. So A intersect B. Oh, sorry, no, A complement intersect B. So I'm gonna use this diagram for my answer, but I'm going to do some scratch work to show you how exactly we figure out what the answer should be. Alright, so over here, I'll draw my scratch work. Okay, so I want to take A complement intersect B. So in my scratch work, I'm going to draw the Venn diagram for A complement. Alright, so A complement, you'll remember, is everything outside the circle for A. And of course, I'll also draw a Venn diagram for B. So when I'm doing these scratch works for my Venn diagrams, I'm drawing kind of intermediate Venn diagrams. Okay, now, if I'm looking for the intersection between this set and this set, I want the stuff that is shaded in both diagrams. Alright, so the outside here will not be shaded because that is not shaded here. This won't be shaded, and this won't be shaded. The only thing that is shaded in both diagrams is this little kind of crescent moon looking shape right here. So that is A complement intersect B. That's shaded here, and it's shaded here. Nothing else is shaded in both. Okay, so when you're talking about intersection and Venn diagrams, look at what's shaded in both of the Venn diagrams that are in your scratch work. Okay, now this is something we can actually build on with previous work, this next example. A intersect B complement. Well, over here we got A intersect B, and we want the complement of that. So in other words, we want the opposite of that. So using our previous work, we can see that A intersect B complement would be everything except what we have shaded in here. So it would look like this. Okay. So, the rules for dealing with Venn diagrams. If you see a union between two sets in your Venn diagram, you're going to shade both of those sets. You're going to combine the shading and get more shading. If you have an intersection between sets in a Venn diagram, you're going to look for the overlap of the shading. And if you have a complement when you're dealing with a Venn diagram, you're going to shade everything else. Okay, now there's one more kind of example I want to look at, and that's when you have a Venn diagram where you're listing elements in different places in your Venn diagram. So this example is a little bit different. A couple of reasons. We have three sets, and we're not going to do shading in this example. We're going to place the various numbers in the appropriate places. So what I'm going to need are three circles because I have three sets. Alright, so I'll need a circle representing A, which I'll put over here like that. I'll need a circle representing B, which I'll put over here, and a circle for C. The box represents the universal set. One thing to note here is that each number should appear only once in the picture. Okay, so we got to think a little bit about where we're going to put the various numbers. In other words, you can't just do something like this. 1, 4, 5, 7. That's a no-no. The 4 shouldn't be here because the 4 should also belong to B. All right, so I'm going to need to kind of erase all that because that's not what we want to do. So give me a clean slate there. Okay, gonna have to fix that, but that's okay. All right. So let me look at all the sets here. The 1, that just belongs to A. No other set has the 1. So I can put the 1 in this region here of stuff that just belongs to A. As we saw before, the 4 belongs to B and it also belongs to C. So the 4 needs to be in the overlap of all of them. The 5 belongs to A and B but not C, so that's this region right here. It's inside the circle for A, it's inside the circle for B, but outside the circle for C. And my 7, so looks like 7 belongs to just A, so 7 should go there. So the circle for A has 1, 4, 5, and 7. All right, now let's look at the circle for B. We got to have 2, 3, 4, 5, and 6. We already have 4 and 5 in the circle, so we need to put 2, 3, and 6 in here. Okay, now the 2 should go here, but the 3 and the 6 need to go in here, because notice 3 and 6 also belong to C. So my circle for B has 2, 3, 4, 5, and 6. The 4 belongs to A, B, and C. That's why it's in that overlap of all three. The 5 belongs to A and B. That's why it's here. 3 and 6 belong to B and C. So that's why those two are in that section. All right, now the circle for C should have 3, 4, 6, and 9. We already have 3, 4, and 6 in there. The only thing left to do is put the 9 somewhere. And since C is the only set with 9, it should go over there. Now, I want you to look at this universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 9. I don't have the 8. The 8 wasn't an element of A, wasn't an element of B, wasn't part of C either. So that's inside the universal set, but it's outside all of those. Okay, so if you run into a situation where they ask you to create a Venn diagram and put the elements in the Venn diagram, you got to do something like this. Okay, each number should appear in the picture exactly once, and you got to think ahead. You can't just focus on A by itself. Okay, because we can see, all right, the 4, that's got to belong to the circle for B and C as well. So that tells us where to put that 4. Okay, so Venn diagrams give us a useful way to visualize sets.